Hello, I'm Yu. This is the third of the series of video on vector space classification. In this video, I will introduce another classification method, k-nearest neighbors. K-nearest neighbor is also called KNN. Unlike Rachel, KNN classification determines the deletion boundary locally. When k is equal to 1, we call it 1NN. For 1NN, we assign each document to the class of its close neighborhood. For KNN, we assign each document to the majority class of its k close neighborhoods, where k is a parameter. The rationale of KNN classification is that based on the contiguity hypothesis, which we talked in the first video, we expect a text document D to have the same label as the training documents located in the local region surrounding D. Deletion boundary in 1NN are containing segments of the Voronoi tessellation as shown. The Voronoi tessellation of a set of objects decomposes space into Voronoi cells, where each object cell consists of all points that are closer to the object than to other objects. In our case, the objects are documents. As you can see, for now, if we use 1NN, the star will be assigned to circle group. And if we use k value is 3, the star will be assigned to other group. 1NN is not very robust. The classification decision of each test document relies on the class of a single training document, which may be incorrectly labeled. KNN for k larger than 1 is more robust. It assigns documents to the majority class of their k closest neighborhood with time broken randomly. Let's look at k-nearest neighborhood algorithm. It is easy to train than the training of Rachel classification. First, the sets are processing the document and select the value for the k. Then we have the train set and the value for the k. To apply k-nearest neighbor, the first step is to select the nearest neighbors of a given document. Then for every possible class estimation, the probability that the given document is in that class based on the intersection of the given document's neighbors and the select class. The max probability is returned as a result. In KNN classification, we do not perform any estimation of parameters as we do in Rachel classification, which is centralized. KNN simply memorizes all examples in the training set and then compare the text documents to them. For this reason, KNN is also called memory-based learning or instant-based learning. It is usually desirable to have as much training data as possible in machine learning, but in KNN, large training set comes with a service efficiency penalty in classification. Let's use the Skittle examples to see how k-nearest neighborhood classification method works. Don't forget that each Skittle represents one document, and there are 3 topics or groups, which are China, UK, and Kenya. The blue Skittles represents the test case. For the blue one, there are 5 nearest documents, and the distance from the blue one to these 5 documents are ordered as the nearest to the farthest, which means that the D1 is the shortest and D5 is the longest. When we select the value of k as 1, which is one nearest neighborhood, the blue Skittle belongs to the topic of Kenya because the document 1 is the nearest document. When we set the value of k at 3, the 3 nearest documents to blue Skittle are document 1, 2, 3, because their document 2 and 3 belong to the topic of UK, and only one document belongs to the topic Kenya. Therefore, the probability that the test document belongs to UK group is higher. The blue Skittle will be assigned to group UK. When k is 5, the blue Skittle will be classified into group Kenya, due to the high probability that 3 out of 5 documents belong to this group. When we select the value of the k, odd number is better than even number. Thank you for watching this video. Please check the next video focusing on linear reverse nonlinear classifiers.